Hi, this is Professor Bowles, and I'm here to show an example of solving an optimization problem. As I solve this problem, I will illustrate the steps for solving a general optimization problem. The problem we are solving is, suppose a farmer has 3,200 feet of fencing. He wants to fence in a rectangular field that borders a river. He will need to fence 3 sides because he does not need fencing along the river. What are the dimensions of the field that has the largest area? As we read the problem, we note that the farmer has 3,200 feet of fencing. He is fencing in 3 sides of a rectangle. He wants the rectangle to have a maximum area. So the diagram we draw shows the river and the 3 sides of the rectangle. The diagram just needs to be a simple illustration to help you see what the problem is about. Next, we will need to introduce notation. We will call the depth or width of the rectangle by the variable x and the length by the variable y. We note that there are 2 sides of length x and 1 of length y. The quantity that we are maximizing is area, and we will let A represent the area. Area of a rectangle equals length times width. So we have that A equals x times y. To get the equation of the area in terms of one variable, we will use the amount of fencing available. The 3,200 feet of fence will cover the side of length x, the side of length y, and a second side of length x. This makes 3,200 equal to 2 times x plus y. Solving this equation for y gives us that y equals 3,200 minus 2x. Substituting this into the area equation gives us A equals x times the quantity, 3,200 minus 2x. By distributing in the x, the area equation becomes A equals 3,200x minus 2 times x squared. Now we will employ our calculus techniques. So we'll find the derivative of A. The derivative of A equals 3,200 minus 4x. To find the critical numbers, we set the derivative equal to 0. Solving that equation gives the answer x equals 800. By looking at the second derivative, which is a constant -4, we see that the second derivative of 800 is negative, and the first derivative of 800 equals 0. The second derivative test proves that the area is a maximum if x equals 800. If x equals 800 and y equals 3,200 minus 2 times 800, this gives us y equals 1,600. The solution to the problem is the width is 800 feet and the length is 1,600 feet. This is the solution to our problem. We used the outlined steps. First, the problem was read carefully. Then a diagram was drawn and notation was introduced. The area was represented by variables. We needed the area in terms of x only. By using the amount of fencing, we were able to write area only in terms of x. The method of using derivative was then used to find the value of x, which gives a maximum area. The second derivative test proved that the value of x gives a maximum value for the area. We complete the problem by making sure we answered the question. This is just one example of using derivatives to show an optimization problem. Thank you.